Hello, my name is Andrew Geary, and welcome to Seismic Sound-Off, in-depth conversations in applied geophysics. In this episode, we preview Xinming Wu's upcoming honorary lecturer tour in South and East Asia on deep learning for seismic interpretation. Xinming and I discuss how deep learning can improve training data sets, the importance of open software packages, the value of understanding seismic interpretation across the workflow, and what would happen if this topic reached its full potential. Xinming Wu serves as a professor at the University of Science and Technology of China, where he started the Computational Interpretation Group. Xinming received an engineering degree in geophysics, a master's in geophysics, and a Ph.D. in geophysics from the Colorado School of Mines, where he was a member working with Dave Hale at the Center for Wave Phenomena. This interview offers an important look at the current state and future for seismic interpretation. Let's get started. So if you would, could you please provide just a brief overview of what your upcoming honorary lecturer tour is going to be about?
Sure, yes. So with this lecture tour, I will basically talk about computer-assisted and actually mostly deep learning-based seismic interpretation. Seismic interpretation typically involves extracting all kinds of geologic features, maybe including faults, horizons, unconformities, and geobodies from 3D seismic images. So today we have been acquiring more and more larger and larger 3D seismic values, but how to efficiently and accurately interpret these values remains an unsolved problem. So we spent hundreds of millions of dollars or even thousands of millions of dollars to obtain such a big 3D seismic value, but this kind of expensive seismic value is not actually fully interpreted or is not fully utilized. So in this lecture tour, I would like to share our experience of using the technique of deep learning or convolutional neural network to try to improve our seismic interpretation. So specifically, I will talk about how to reasonably formulate our seismic interpretation tasks as proper deep learning problems. And I will also talk about how to prepare training data sets and how to train these deep neural networks. And I will also show the result, how these results of deep learning compare with the conventional automatic seismic interpretation methods. And I will also talk about how we can do more in the future for the topics.
Well, you mentioned it there in your answer there about convolutional neural networks you mentioned, and they play a major role in your lecture. So what are these convolutional neural networks, or CNNs, as you call them?
Yeah, so in deep learning, convolutional neural network is simply one type of a deep neural network. We call it convolutional neural network because we employ the convolutional operator at each layer of the neural network. And the convolutional neural network has been widely used and actually shown very powerful performance in image processing, especially the multi-dimensional image or array processing tasks, including the object detection, image segmentation, and image classification problems. And most of our seismic interpretation tasks can be considered as multiple dimension image processing or array processing problems. So we therefore use a lot of convolutional neural networks for our seismic interpretation problems.
One issue you mentioned involving CNNs is the preparation of training data sets. Why is this an issue, and how do you propose to address it?
Oh yes, this is a big part of deep learning. So in the deep learning methods, especially in the supervised learning methods, so a very important step is to prepare diverse and reasonable training data sets, so which typically includes the input data in our case is the input seismic images and the target interpretation results or the labeled images. So in our seismic interpretation problems, we do have a lot of input seismic images, but we do not a lot of labels. We have only very limited interpretation results or labeled images. Because interpreting or labeling 3D seismic image is very time consuming, and therefore it is really hard to manually prepare a lot of training labels. In addition, the manual interpretation or manual labeling is highly subjective. So basically, different interpreters often provide different interpretation results. And it is really hard to fully interpret a seismic image. So if we have any like missed labeling or wrong labeling, and these cases will actually mislead the training process. So to be able to kind of solve these problems, I will talk about a possible way to automatically build a lot of subsurface models, which contains different kinds of geologic features, structures, geobodies, and based on the subsurface models, we will further simulate the corresponding synthetic seismic images, which will contain the same geologic features as in the subsurface models. And because these geologic features are well defined in the subsurface models, we are able to automatically label the target geologic features in the seismic images. So in this way, we are able to obtain a lot of diverse training data sets, including the input seismic images and the target labels, where all these labels are 100% accurate. So we don't need to do any manual labeling, and these labels are accurate, are reliable. And to ensure the diversity and the generality of the training data sets, all these geologic features are randomly generated in the models, but following some geological knowledge and patterns.
It is not too difficult to imagine how valuable that would be, for sure. And, going back to other things you're going to be talking about in your talk, you're going to be providing your research experience on these convolutional neural networks for a wide range of topics, not just training data sets, including fault detection, seismic horizons, seismic geobody tracking. Of all the topics you're going to highlight, what topic are you most excited to share with your audience?
Yeah, I will say that all these topics will be like equally interesting and important for the lecture, and I think each topic is equally important as well for the seismic interpretation. So here in this lecture, I'm trying to put all these different topics together in one lecture, because I think it will be helpful to answer the following questions. So the first question is that how to properly formulate a specific seismic interpretation task as a proper deep learning problem. For example, we consider the fault interpretation as an image segmentation problem, and we consider the horizon interpretation as a regression problem. So while the geobody detection is considered as a segmentation or like classification problem. And the seismic image processing as a like multitask learning problem. So although these topics are all like related to seismic interpretation, but we formulate these topics as different deep learning problems. So we put this together, we are able to do some comparison. And this is a very important question that we want to ask when we try to use deep learning to solve our interpretation problems. So the second question it will be helpful to ask by combining these topics together is that how to choose a proper deep convolutional neural network for a specific seismic interpretation task. So here, for each topic, we actually use a different network. And one more thing I want to say here is that this lecture is actually not just limited to these topics of seismic interpretation. I will also discuss or like briefly talk about some of our latest research work on deep learning for seismic migration, seismic imaging, and geophysical inversion problems. I will also show some deep learning for some other geoscience data processing, like we use deep learning to automatically processing the marine data, and we use deep learning to process the images from the moons, the Mars, the planets. So all kinds of geoscience data sets. Yeah.
One of the really exciting things about these tours is you get to go a bunch of different places and get to engage and interact with a bunch of scientists and smart geophysicists. What are you most excited possibly to get feedback from your audience to help you with maybe your next iteration of your own research?
Oh yeah, this is a very good question. Thanks for asking about that. So, yes, I believe a lot of audience have been working on the similar topics by using deep learning or some other methods, and I believe many of them have done even better than us on these topics. So I would expect to discuss with the audience and would like to hear their progress and their research, their experience on these topics. And in addition, we actually have made some of our software packages public on GitHub, and we will make even more packages public recently. So I expect to hear their comments or suggestions on our software packages as well if they had a chance to use them. So I recently got some suggestions, some feedbacks from LinkedIn, Facebook, because they are, some of them are using our software packages, and they really have some very good suggestions on the packages.
That's great. For people attending your lecture, what do you expect or hope will be some of the takeaways for attendees?
Yeah, so the first thing is that about deep learning. So if used well, I think deep learning will be a very powerful technique for solving all kinds of geoscience problem. And the second thing is that in this lecture, I would mainly talk about that we train the deep learning convolutional neural networks by using synthetic data sets. And our example shown that from these synthetic data sets, the network can effectively learn to interpret the structural features in the field seismic images. And the third thing is that deep learning is actually encourages collaborations of people from different areas. And on the other hand, deep learning is also like reducing gaps among different areas. For example, we collaborate with macro software, we collaborate with NVIDIA, collaborate with Huawei on this on our geoscience problems. So they are all from different areas. So the last thing is that deep learning encourages public software packages and sharing data. So I really encourage people from like geophysics, from geoscience, to try to like share our data sets, share our to make our software packages public. So this will be very helpful for deep learning in our geoscience problems. Yeah.
Well, we will link those software packages on the notes of this podcast so people will be able to find it there as well. What personally excites you about the future of this topic?
Yes, for this topic, with our like this recent 4 years experience, we did see the powerful performance of deep learning in seismic interpretation. As I said, for myself, I have worked on like this seismic interpretation topics for 10 years. For the first 6 years, we tried to use like conventional image processing or like solving for partial differential equation to try to automatically interpret seismic images. But for the recent 4 years, we start using deep learning on the similar topics, and we realized that deep learning can significantly improve the results of the seismic interpretation compared to the conventional like, methods. So I would expect to see that deep learning can like in the future can significantly reduce the intensive human labor that is still required in seismic interpretation tasks, so that we can focus on more interesting research problems based on the interpretation results from deep learning. So we don't need to do a lot of human labeling or human interpretation to pick faults or horizons. Yeah, I would expect deep learning could do this for us. So we can directly work on the interpretation results for science problem, for more interesting problems.
That the future of this topic, kind of building off this question here. So please finish this sentence. If deep learning for seismic interpretation reached its full potential, it could.
So right now, for the seismic interpretation, we still spend a lot of time to try to just pick the horizons or pick the faults. So I would say that the deep learning could do this for us, and then we can just focus on more science problem. Of course, that maybe in the future deep learning can also try to tell a geologic history, a story based on the seismic image. So and this is right now done by geologists, right? So the geologists look at the data and they will be able to tell a story about of the geology behind the data sets. But maybe in the future, the deep learning can also do some kind of this this problem as well. Not just picking fault, picking horizons, or picking geobodies.
Well, very early on in your career, you've already been recognized quite a few times for your past research, including Best Paper in Geophysics. You've received the Shanghai Excellent Master Thesis Award. As someone going on this honorary lecture tour as well, what one piece of advice would you offer someone that would like to succeed in your field?
So I think that it's also related to this lecture. I will encourage the students to read papers to read papers from some other areas, especially for from computer science. So for me, I will read a lot of papers from the top meetings of computer science. For example, the CVPR, NAIPS. So I will get a lot of ideas, very interesting ideas from the computer science area, and also I will encourage students, if you are geophysics students, you probably want to know more about geology, and if you are geologists, you might want to know more about geophysics, of course, because right now with deep learning, we are trying to combine knowledge or data sets from different areas, from different fields to get a better understanding of the subsurface. So because knowing more about the subsurface is the goal for all geophysicists and for all geologists. So now we are trying to use techniques from computer science to combine the knowledge of all the theories or the information from geophysics and the geology to do better for the goal.
Thank you for that very helpful advice to many people listening here. Is there anything in particular that I did not ask that I should have asked?
Yeah, you basically asked most of the questions most of the things that I would share with the audience. But there's one more thing that I maybe already mentioned in the previous interview, but I want to emphasize that the title of this lecture is Deep Learning for Seismic Interpretation, but actually the topics will not be limited to seismic interpretation, and because I will also talk about our recent work on deep learning for seismic migration, geophysical inversion problems, and different kinds of geoscience data set processing. And more importantly, these methods used for seismic interpretation can also be applied to many other problems in geoscience. So I will encourage people from all different kinds of geoscience majors come to this lecture.
That is a great reminder there for people listening. I appreciate your time and getting up early this morning to speak with me, and look forward to sharing your talk with your upcoming tour.
Thanks.
Thank you for listening to SEG's flagship podcast. Please share this episode with a friend, colleague, or manager that would enjoy hearing this episode. Your recommendation is the single best action you can take on behalf of SEG's podcast. Go to our website at seg.org/podcast to find all our episodes and learn how you can listen to this podcast directly on your phone without downloading an app. Original music by Zach Bridges. This episode was hosted, edited, and produced by me, Andrew Geary. The SEG podcast team is Jennifer Crockett, Allie McGinnis, and Mick Sweeney. Thank you for listening. This is Seismic Sound Off, signaling off.